Earth's magnetic field has weakened by 9% over the past 200 years. If this trend continues, it could weaken significantly within the next 1,600 years. Recently, scientists discovered through observations by the European Space Agency's Swarm satellite that the global magnetic field has dropped by an average of 9% in the past 2 centuries. If this continues, Earth could lose its magnetic field, transforming from a blue planet into a red desert planet like Mars. Although we cannot yet explore Earth's core directly, scientists believe that the magnetic field is generated by the movement of liquid iron in the outer core, acting like a giant dynamo that creates the magnetic field flowing between the North and South poles. This magnetic shield blocks harmful solar wind, streams of high-energy charged particles. Without it, these particles would strip away Earth's atmosphere layer by layer. In the past 200 years, the magnetic field's strength has decreased by 9%, with the decline being particularly pronounced in the South Atlantic anomaly, where the field is about 30% weaker than the global average. Satellites passing through this region often experience disruptions. Scientists estimate that the magnetic field weakens by about 5% to 6% per century. If this trend continues, it could approach zero within 1,600 years. However, geological records show that Earth's magnetic field has never been stable. It fluctuates naturally. Over the past 7,000 years, the average strength of the magnetic field has remained consistent, and polarity reversals occur roughly every 250,000 years. During these reversals, the magnetic field intensity drops significantly, but does not disappear entirely. Mars offers a cautionary tale. 4 billion years ago, it was likely a wet world with rivers, lakes, and possibly the conditions necessary for life. At the time, Mars had a powerful global magnetic field protecting its atmosphere and oceans. However, Mars' smaller mass caused its core to cool too quickly, halting the flow of liquid iron and collapsing its magnetic field. Without this shield, solar winds stripped away most of Mars' atmosphere, leaving it the barren red desert we see today. Earth, however, is very different. With a diameter of approximately 12,742 kilometers, Earth's core is significantly larger than Mars's, with a solid inner core about 1,220 kilometers thick, surrounded by a liquid outer core. Additionally, Earth's core temperature exceeds 5,000 degrees Celsius, sustained by the decay of radioactive elements and residual primordial heat. Scientists estimate that Earth's geodynamo will continue operating for billions of years, ensuring the magnetic field remains active for at least another billion years. Even if Earth's magnetic field weakens significantly, our dense atmosphere and strong gravity would prevent immediate loss of atmospheric gases, unlike what happened on Mars. In the coming centuries, humanity aims to terraform Mars, but the first step will be restoring its magnetic field. Otherwise, even if Mars' polar ice caps were melted and oceans reshaped, liquid water would not persist on the surface for long without a magnetic field. Until then, building underground habitats on Mars may be the best way to protect against radiation and sandstorms.